It's time to check out Btrfs. Btrfs? Btrfs? Wait, what was I supposed to call this one again? Hello again, everyone, and welcome back to Learn Linux TV. It's finally time to check out Btrfs, and this is actually something that I've been wanting to check out for quite some time now. Btrfs is a file system, but not just any file system, at least not in the usual sense. In addition to being a file system, Btrfs actually adds some really exciting new features on top of its file system component that are very exciting. So in today's video, what we're going to do is first define what Btrfs even is in the first place. I mean, yes, we know it's a file system, but I mentioned that it's a lot more than that. So we'll first define what makes Btrfs stand apart from other file systems out there. After we do that, we'll talk about some of the controversy and history around Btrfs. That way you could have a better understanding of where Btrfs actually stands at this current point in time. And then after we do that, I'll show you some examples of Btrfs in action. But before we get into all of that, I want to take a moment to mention the sponsor for today's video, Linode. Linode is a Linux-focused cloud server provider, and using their platform, you could actually set up your very own Cloud Linux server in minutes. You could use Linode's platform to set up your own blog, perhaps a Nextcloud server, a Minecraft server, but if you're not feeling particularly creative today, then you can actually use their platform to spin up a Linux instance that you can use while going through the tutorials in this series. In fact, they have all kinds of distributions available, so if it's covered on Learn Linux TV, then you could probably find it on Linode. And best of all, cloud servers on Linode's platform are very inexpensive. You can get started with a Linux instance for just $5 a month, but it's even more affordable because if you use the URL that's on the screen right now, then you'll be able to set up your brand new Linode account with $100 in credit, and you can fit quite a few Linux servers within that credit. The credit is actually good for 60 days, and I highly recommend you check out Linode's platform because they are awesome. So thank you yet again to Linode for sponsoring today's video. I really appreciate it. And with all that out of the way, let's go ahead and get started with Btrfs. Alright, so in this section, what we're going to do is go over what Btrfs actually is, as well as some of its history. Now, the first thing that I'd like to get out of the way is how you pronounce it. I've actually heard of it pronounced as Btrfs as well as Btrfs. And the thing is, these pronunciations are pretty much valid. But considering that I've most often heard of it being pronounced as Btrfs, that's how I pronounce it on my end. But anyway, what exactly is Btrfs? Well, I've already mentioned that it's a file system, so you already know at least that so far. However, it's not a simple file system, at least not in the common sense. Historically, file systems have existed as a means to define how data is stored on storage volumes. And many file systems actually stop right there and do nothing more than that. Btrfs is more of a modern take on the concept of a file system. Like others, it controls how data is being written to your storage devices, but with Btrfs, that's only just the beginning. In addition to defining how data is stored, it also includes additional features that are intended to protect your data against things like bit rot, give you access to create snapshots, and can even go as far as to manage multiple disks as if they were all on a single volume. Another important aspect of Btrfs that I need to mention is that it's a copy-on-write file system. That's an important distinction. Now, a full explanation of what a copy-on-write file system actually is would be a video in and of itself. But a quick summary of what that means is that such a file system copies data anytime there's a modification, rather than immediately overwriting it. This actually helps ensure data integrity. For example, in a situation where power is lost to the entire device in the middle of a write, if this were to happen on a storage volume that utilized Btrfs, the original data would be saved during such an event, and the reason for that is because new or unmodified data would be copied and written somewhere else first, which increases stability. In fact, my friend Tom Lawrence has an entire video regarding copy-on-write on his channel, which I highly recommend that you check out. Anyway, even though Btrfs is a copy-on-write file system, you can actually disable the copy-on-write functionality if you have a reason to do so, and this makes Btrfs a file system that adopts copy-on-write rather than one that requires it. Today, Btrfs is actually the most advanced file system that's built into the Linux kernel. In fact, if you currently run a Linux workstation or server, there's a very good chance that you already have access to Btrfs, and some distributions of Linux actually go as far as to set it as the default, with SUSE and Fedora being two examples of that. So already, you might be thinking that if Btrfs is trusted by those distributions, then that can only mean that it's ready for prime time and it's time to switch to it. But not so fast. In the next section, what we're going to do is discuss the pros and cons of Btrfs. It's definitely important that we understand what makes Btrfs great, and also what its shortcomings are. Now let's talk about the pros and cons of Btrfs in this section. I mean, Btrfs actually sounds great so far. I've mentioned some of its many features that set it apart from other file systems, but should you use it? That's actually the question that I'm going to try to help answer in this section, and I'll do so by going over its pros and cons. Since storage needs are different from one user to the next and one use case to the next, understanding the pros and cons will help you make a determination as far as whether or not Btrfs is something that you might want to consider. So to get this section started, let's go over some of the pros, and I'm going to do so in no particular order. First, snapshots. As an administrator myself, I love snapshots, regardless of where it's implemented. Taking a snapshot allows you to preserve the state of something at a particular point in time, and then revert back to it later if you need to. A good example of this is installing updates. Imagine taking a snapshot before you install updates, and then later finding out that, unfortunately, one of the updates that you've installed is causing a problem. If you just so happen to have taken a snapshot before updating, you can actually revert your entire installation back to the state your device was in before the updates were even installed. And this lets you test things out before making anything final. Now, the ability to take a snapshot isn't new. In fact, it's very common when it comes to technologies like virtualization. But if you're an administrator like I am, I'm sure you'll appreciate any ability to freeze something or have a reference to a certain state, and then be able to return exactly to that state if you need to do so. With Btrfs, you have the ability to take snapshots of your storage volumes, which gives you added protection. Just like you're able to do with virtual machines, you could take a snapshot of your file system, or even just a subvolume, and then later revert back to that snapshot in the future if you need to do so. Since Btrfs snapshots are implemented at the storage level, you won't be able to take a snapshot of the entire state of the virtual machine, but having the ability to take a snapshot of a storage volume is definitely a nice feature to have. Another feature of Btrfs that's really exciting is the ability to create subvolumes. Subvolumes can be thought of as partitions, but that's actually an oversimplification of what they actually are. We'll talk more about that later. Subvolumes themselves actually keep track of size differently than, partitions might, and that means you get additional features with Btrfs subvolumes when compared to partitions. If you were to actually compare Btrfs subvolumes to partitions, the overall implementation is actually different even if the purpose is the same. So I guess you could think of subvolumes as partitions in the normal sense, but implemented a bit differently, and they have additional features as well. We'll talk more about subvolumes later in the video, but I just wanted to call them out right here because it is actually a feature of Btrfs, something that I think is definitely noteworthy, and we're going to cover it, and I'll show you exactly how they differ from normal partitions, but just keep in mind that subvolumes are actually similar to partitions, but they're implemented quite differently. Continuing, checksums are another feature when it comes to Btrfs, and checksums help us ensure that data integrity is maintained. Generally speaking, when we save information on a storage device, we generally want that information to be safe from things like bit rot or anything else that might constitute a potential issue with data integrity. Checksums in Btrfs help us address that. Now those are just some of the benefits of Btrfs. There's quite a few features, but already the features that I've mentioned are quite exciting. Well, at least they are in my opinion. When I was reading about the feature set of Btrfs, I couldn't wait to check it out. But as with pretty much everything, where there's pros, there's also cons. And one of the difficulties that you might run into when it comes to Btrfs is how it implements RAID. Btrfs, like ZFS, has a built-in implementation of RAID that's separate from, something like MD RAID that you might use on Linux manually. However, the implementation of RAID in Btrfs does actually take some liberties when it comes to RAID as you are normally aware of it. So if you were looking at, RAID 1 when it comes to standard RAID versus RAID 1 in Btrfs, there's going to be some differences in things that sets one apart from the other. So if you're planning on using RAID in Btrfs, then you should at least understand how it differs. But I'm not actually going to go over RAID when it comes to this particular video because RAID is in a very weird state in Btrfs. You actually shouldn't use it. Btrfs is being highly developed right now. There's all kinds of people working on this, but as of the time I'm recording this video, RAID is just not something you should consider if you're using Btrfs. That doesn't mean you can't use it. That doesn't mean you won't have a good experience. But there's enough instability when it comes to RAID and Btrfs to where I need to recommend to you to just pretty much avoid it for now. But RAID isn't the only difficulty that you might run into when it comes to Btrfs. It's actually a good idea to consult the official documentation, because in the documentation, there's actually a status page that outlines which features are considered stable and which features might need a bit more work to get them stabilized. Normally what I would do is outline the state of those features in this video to give you a full understanding. However, since Btrfs is being readily developed, this information will constantly change, so make sure you check the list by visiting the page yourself to see if anything has changed since this video was recorded. In the description down below, I'll have a link to the status page in the Btrfs documentation, and on that status page, you'll find a list of the available features and whether or not they're considered stable. If you're planning on implementing Btrfs, then I urge you to read that document first before you proceed. Another con regarding Btrfs is that it has somewhat of a reputation of being unstable to the point where some people actually accuse it of eating their data. And that certainly sounds horrible, doesn't it? The main job of a file system is to keep your data safe, and if it's not going to do at least that, then you could argue that represents a potential huge issue. But then again, keep in mind that Fedora and SUSE seem to think that it's safe enough to implement as the default file system, so it really depends on how you use Btrfs, and that makes all the difference. So already, at this point in the video, you could probably argue that I'm not really doing a great job of selling you into Btrfs. I mean, one minute I'm praising it for the features that it has, but then the next minute I'm talking to you guys about the reputation that it might eat your data. And I don't know about you, but as soon as somebody mentions that something might eat my data, I'm, really not interested anymore in using it. At the end of the day, whether or not you lose data depends solely on your disaster prevention plan. And if you do lose data, well, it's time to dust off your data recovery plan. It is not the job of your hard drive to stop you from losing data. It's not the job of your RAID card or software RAID or your file system to keep you from losing data. That's solely on you and you alone. We can't blame our storage devices. We can't blame our hardware. There's a reason why we have backups, we have snapshots, we have, load balancers and redundancy and clusters. We have those things because storage is not predictable regardless of what the technology happens to be. So in this case, yes, there are some actual concerns about some of the features and the stability of some of those features in Btrfs. Well, that's why we have these other technologies that I've mentioned. We have backups, we have warm sites, cold sites, we have all these different things at our disposal that we can use to get ourselves out of a jam if we end up in one. But all things considered, as long as you pay attention to the status of Btrfs, you should be fine. So at this point, let's go ahead and take a look at Btrfs in action. What you see right here is a fresh installation of Fedora 36. Now you can certainly check out the recent review that I've done for Fedora 36, but the reason why I'm actually showing you Fedora in this particular video is because it's a great way to get started with Btrfs. And the reason why that's the case is because Fedora actually defaults to Btrfs. So if you do a standard installation of Fedora on your desktop or laptop, then congratulations, you are already using Btrfs. So I figured that showing you guys Btrfs as it is here in Fedora would be a great way to get started. So first of all, what I'm going to do is open up GNOME disks. And here we can start to get a look at how the Btrfs implementation is actually set up. So in my case, I have a 512 gigabyte SSD here on my Studio PC, and if I click on that, you can see right here that we have 3 different partitions. We have a FAT partition, we also have an ext4 partition, and these are actually for the boot process, so we're going to ignore those. But the largest partition right here, this is actually, as it shows, a Btrfs partition. And in my case, I didn't do anything special when I set up this distribution. Again, Fedora defaults to Btrfs, so unless you tell it otherwise, then Btrfs, that's what you're going to get. Now, if I open up a terminal, we can actually explore this a little bit deeper. Anyway, I'm going to show you guys some commands right now that are going to help us explore Btrfs. And I suppose that I don't need this anymore. And then I can enlarge the terminal. Anyway, what I'm going to do right now is use a few commands to show you the implementation of Btrfs. So for example, I can use the fdisk command with sudo in front of it, followed by -l, and what this will do is give me a listing of the storage devices on my computer. I only have one anyway, so if I press enter, and then type in my password, it's going to show me some information about my main hard drive. And as you can see right here, like I mentioned, I have a 512 gigabyte SSD, and then we have 3 partitions. So essentially, the information that you're seeing right here is the same information as we saw in GNOME disks. Now, if I take a look at the fstab file, we begin to have a look at how exactly this is implemented. So right here, we see Btrfs listed twice. Right here, we have the root file system. So of course, that's where our Fedora installation actually is. And we can see right here that the type of file system that is showing right here in the fstab file, it's of course a Btrfs volume. We also have a partition right here for /home, and that's also a Btrfs volume. So this is the default Fedora partition layout right here unchanged, where I've just simply accepted all the defaults while I install this distribution. Now I mentioned that we have a home partition and then a partition for our root file system, but those aren't actually partitions. I mean, yes, they're treated like partitions. They have separate mount points, as you see here, but actually what these are subvolumes. And we can see that here because for the root file system, the name of the subvolume is root. And then of course for the home directory, the name of the subvolume is home. So that's pretty simple. But what exactly is a subvolume? Let's go ahead and explore that next because, well, that's a very important aspect of Btrfs, and it's definitely something that we'll need to define so that way we could better understand the remaining concepts that I'll be going over in this video. Now, I actually mentioned partition several times, and I also mentioned that subvolumes are not partitions, so what exactly are they? Now, they are treated as partitions, especially when it comes to being mounted. I mean, right here, the home directory as well as the root file system, they're considered independent mounts. So if you didn't know any better, you would probably consider these right here to be partitions in every sense of the word. But actually, look closer. Right here, we have the universally unique identifier for this particular partition. And yes, I called it a partition. I'll define the difference in a moment. I'm just simplifying it. But anyway, the UUID is this right here. And if you didn't already know, the UUID is actually an identifier for a storage device like a partition. And the UUID doesn't actually change at all. So regardless of if you, I don't know, pull out the hard drive and put it in a different slot on your computer, then it's always going to have the same UUID. The UUID follows the partition or storage device regardless of where you put it. That's why we use UUIDs, because it just helps us make better sense or better target the very specific storage volume that we want to. But if you look at the identifier for the home folder right here at the bottom, you'll see that it has the same universally unique identifier. Okay, that doesn't sound very unique, does it? I mean, we have 2 different devices and they have the same UUID. Is that even possible? Well, it must be possible because a coincidence like this, I mean, you'd probably have a better chance of winning the lottery than having 2 devices share the same UUID if they're different devices. So what we have right here is the same device listed twice. So /home right here and the root file system, they're on the same device. That's very important to understand. They are subvolumes. So right here we have subvolume root, and of course we have subvolume home, but both of these subvolumes are on the same Btrfs partition. So to take a look even closer, I'll run lsblk, and we do have 3 partitions right here. And if I pull the UUID, which I can do by running this command right here that I'm about to give you, sudo blk id, and then the name of the device, notice right here that the UUID that I grabbed from that 3rd partition is the same as the home directory as well as the root file system. So what that tells us that the device /dev/nvme0n1p3, basically the third partition of the first NVMe drive, that partition right here is the one that's being used for both of these right here. And it's right here that we actually get to the first difference between subvolumes and partitions. Partitions are, in and of themselves, considered different devices on a Linux system. And technically that's still the case here because we have partition 1, partition 2, and partition 3. These are indeed different partitions in every sense of the word. These are actual partitions and not subvolumes. But this last partition right here contains the entirety of our Btrfs implementation. But anyway, we understand we have 3 partitions, and that instead of, actual partitions for the home folder and the root file system, those are both subvolumes on the same partition, and this might actually be confusing you more. So what I'm going to do right now is show you guys some visuals that are going to help you better understand the actual difference between subvolumes and standard partitions. So here's the first visual. For this example, let's say you have, a 200 gigabyte hard disk, and then you set up 30 gigabytes for your Linux distribution, essentially your operating system, and then you give the rest to your home partition. This is actually a very common partition layout, and one of the benefits of this layout is that by having the root file system on a different partition, you can reinstall your entire Linux distribution and not lose any data, at least so long as you don't accidentally also wipe out your home partition as well. This is standard partitioning. If you've ever partitioned a disk before, then what you're seeing right here is actually that same thing, a standard partition layout. And with standard partitioning, like you're seeing here, each partition on your disk represents an actual boundary. For example, let's just say you downloaded a bunch of things and your home partition is completely full. You have no more room to save so much as a single file. You're full, it's at its limit, you can't save anymore. Now that's very unfortunate for your home partition, but it doesn't impact the operating system or the distribution at all because the distribution is on its own partition. So as long as you don't actually fill up your root file system, then the fact that your home directory is full is not really going to negatively impact you other than maybe desktop shenanigans. Your operating system, your distribution, that's going to continue running just fine. And that's one of the reasons why we use different partitions. We want different boundaries. Now let's change to a different visual. And this one is going to show the same concept more or less, but with subvolumes instead of partitions. And here we have essentially the same disk layout as the previous one. But in this example, we have subvolumes instead of partitions. We have a subvolume dedicated for the root file system and another dedicated for the home directory. But we can also see the first big difference between standard partitions and Btrfs subvolumes. Take a look at the size. It's the same for both. But how could that be? Well, the reason for this is that Btrfs subvolumes don't actually have a fixed size like partitions do. Here, either subvolume can use up the entirety of the size of the Btrfs implementation itself. Now, when you compare that to partitions, it's nice to know that if a partition becomes full, the other partitions won't be full themselves. And that's because they're treated as completely separate entities. However, a Btrfs subvolume can use up to the full size of the Btrfs volume, so you don't exactly benefit from that same protection anymore. So, if your home directory actually fills up in this case, then the entirety of your entire Btrfs implementation is now full. The fact that you filled up your home directory is not going to contain it there, since both of the subvolumes can use up the entirety of the disk. So let's go ahead and see our first Btrfs command. For all of these, I'm going to need to use sudo, so I'll start the command with that. And then our user space utility for managing Btrfs, or even just checking the status of our Btrfs implementation, is the Btrfs command, like you see here. And then after that, we type file system and then usage, and then the path to the subvolume. So if I check the root file system, for example, I'll type a single / just like that. And here we get all kinds of information about the usage of our Btrfs implementation, specifically the root file system. We can see how much space is free. So we have quite a bit of space free, as you can see. Over 469 gigabytes are free at this time, which makes sense. I actually just created this particular installation today, and I haven't even had a chance to save anything on it just yet. Now let's see what happens if I do the same thing, but this time I'm going to actually target the home folder. If I scroll up, we have the same amount of space free, as you can see right here. And no, we don't actually have a 1 terabyte disk that's split into two 469 gigabyte partitions. The Btrfs implementation is only one partition, and it actually has 469 gigabytes free. So regardless of which one we take a look at, the free space is the same because they share the free space, whereas, partitions have their own free space each. Btrfs subvolumes share their free space. However, that doesn't mean that you can't have a limit imposed on how much space can be used within a subvolume. For that, we have quotas. And that's what I'm doing in this graphic right here. I'm imposing a quota, and I'm hypothetically doing that to, impose a limit. I'd rather not have a subvolume have the capability of completely filling up the disk. So by using quotas, I'm hypothetically working around the fact that subvolumes don't have the same boundary that partitions have. But it's here that we come to a very important aspect of Btrfs that we need to keep in mind. And I did mention this earlier, but again, not all available features are stable and ready for normal use. On the official status page, which you're seeing right now, it lists the quota feature as mostly okay. Now, I don't know about you, when a feature is listed as mostly okay, when it comes to storage, I'm probably going to ignore that. Yes, there is a way to use quotas and not have a problem. People have done it. And as long as you stay away from certain, combinations of features, you could probably be okay with quotas. But if it's listed as mostly okay and, not fully stable, then I think the best Btrfs experience can only be had if you take that into account and you go along with that and make sure not to use something that's not considered fully stable. Now, in this case, the reason why I'm letting you know that quotas exist is not to tell you to, go ahead and use that feature, but to use it instead as an example of the fact that some features in Btrfs just aren't ready yet. Now, let's go ahead and move on and talk about snapshots. A snapshot allows you to create a pointer to the state of your disk at a very specific point in time. You can use a snapshot to test a configuration change, perhaps a new piece of software, and then you could roll back the snapshot. Then the state of your subvolume, the one that you actually took a snapshot of, will be restored exactly to the way it was when you first took the snapshot. And you know what? The ability to create a snapshot has been largely specific to virtual machine solutions, but we can utilize snapshots with Btrfs regardless of whether our machine or instance is a VM or if it's on actual hardware. Let's go ahead and see it in action. So what I'm going to do right now is create a snapshot of the home folder. If you recall, the home folder on this machine here is actually a Btrfs subvolume. So what I'll do is run sudo Btrfs, and then I'll type subvolume because that's what I want to work with. More specifically, what I'd like to do is create a snapshot of a subvolume. And the subvolume that I want to create a snapshot of is /home. And then we need to give the snapshot a name, but not just a name. We need to tell Btrfs where to mount that snapshot. So what I'll do is underneath /home, I'll just call it home-snapshot-1. I guess that's good enough. And if this works, then I should have a snapshot. So I'll press enter. And it tells me that it's created the snapshot, or it says create a snapshot, but it didn't give me an error. So I think that means that it's actually working. And to verify that, I'll run sudo Btrfs subvolume. And we're typing subvolume because even though we've created a snapshot, that snapshot itself is also a subvolume. And I want to list the subvolumes, and I want to list the subvolumes underneath /home. And check this out. Right here, we have home snapshot 1. So we have taken a snapshot of our home folder just like that. That was super easy. And the syntax is straightforward, as you can see. And in no time at all, I was able to create a snapshot. Now, what I'm actually going to do is make a change. I want to show you guys some sort of change. Otherwise, you won't be able to see this in action. So what I'll do is go over here to a different workspace, and I'll just change the background because that's a very visual change. You'll see that right away. I'm just going to randomly choose a different wallpaper altogether. So at first we had the default Fedora wallpaper. Now we have this one. So I have indeed made a change underneath /home because, well, that's where my user settings are actually saved. So we should be good there. Now on your end, you could just pretend like I've done something drastic, maybe made a huge change or something like that. I mean, obviously you wouldn't want to use snapshots just to roll back a wallpaper change, but the wallpaper change here is just symbolic and it's very visual, which is why I chose it. But on your end, you could probably think of a better alternative than changing the wallpaper. Anyway, how do we go ahead and revert our changes? How do we go back to the state our subvolume was in when we took the snapshot originally? Well, the first thing that we're going to do is grab the subvolume ID, which is actually right here, and subvolume ID 261, that's the ID that corresponds to the snapshot. So we just have to remember 261. Now what I'm going to do is edit the /etc/fstab file. And before we do that, we really should make a backup of it. So what I'll do is just type sudo cp, take a copy of this. I'll just save it right there as fstab.bak. Should be simple enough. And I'm doing that because anytime we're messing with our fstab file, well, that's a bit risky because our system might not boot if we make a change here that isn't actually accurate or if we have a syntax error. Now, of course, we want to be very careful when it comes to modifying the fstab file. If we make a single error inside this file, then our machine will not boot. So on your end, only follow along with me if you're working on a test system and not a production system, because I don't want anyone to hose their production system, messing around with snapshots and things like that. So you definitely want to make sure that you get some practice within a virtual machine before you implement this. So anyway, we made a backup of our fstab file. So let's go ahead and make some changes and see this in action. So I'll just use nano to edit the fstab file. And then we're going to go all the way down here to where we see the home folder. And then I'm going to go all the way to the right. And we're going to change this right here. Now what we could do is change the name right here and also to the left as well, but I don't recommend that at all. It's a lot easier to work with subvolume IDs than subvolume names. So that's why I recommended that we grab the subvolume ID before we go any further. So I will just change this to subvol ID, and then I'll give it the ID number, which was 261. Now we just need to be careful. If you did decide to follow along with me, just take your time, don't rush through this. But anyway, I changed subvol to subvol ID. I set it equal to the actual ID of the snapshot that we've just created. Now remember, this is what the wallpaper looks like right here. I changed it away from the default. And what I'm going to do is save this file. I'll exit out. And let's go ahead and reboot. All right, so moment of truth. We're booting up right now, and hopefully we'll see what the actual snapshot has done for us. So as long as this actually boots, we should be in good shape. All right, so here we have the login screen. So I guess this must be a good sign. If I made a mistake in the fstab file, then I wouldn't be seeing a login screen at all. So far so good. I'll go ahead and type in my super secret password right here. Now wait a minute. That's the previous wallpaper. So if I didn't know any better, I would say our Btrfs snapshot actually worked. But let's actually take another look at this so we can understand fully what exactly just happened. So if I open up a terminal, and let's run sudo Btrfs subvolume list, and then again, we want to list the subvolumes underneath /home. Now again, we have these subvolumes right here. So this home subvolume, that's the one that we started with. And this right here is actually the one that I created. And the one that I highlighted is actually a snapshot. And that snapshot was taken before I changed the wallpaper. So then what I did was I grabbed the subvolume ID, which in this case is 261. I changed subvol to subvol ID in the fstab file. I pointed it to this particular snapshot, and then I rebooted the system. And we have, as you can see, the default Fedora wallpaper. You saw me change the wallpaper to something else. But the thing is, I created the snapshot before I changed the wallpaper. So by pointing the fstab file to the snapshot, I'm effectively pointing it to how things were before I made that change. All right, so in this section, what I'm going to do is show you guys the process of creating your own implementation of Btrfs. Now I'm still using the same Fedora installation that I was using in the previous section, However, right here, I have an SSH connection to a Linode instance that's also running Fedora. In this case, I created an instance of Fedora 35, and I created this before Fedora 36 was actually released, but it shouldn't really matter that this Linode instance right here is one version behind because, well, for our purposes today, it's just not going to make a difference. Now, one thing to note about VPS or cloud instances of Fedora is that often they will not be using Btrfs. So if we take a look at the fstab file, we can see that we're actually using extended 4 right here, so we are not using Btrfs, at least not on this particular instance. But you know what? That's okay, because we can still set up Btrfs, we can still implement Btrfs. It doesn't really make a difference that the root file system is or is not consisting of Btrfs. We can go ahead and just add another volume. So what I'm going to do is switch over here to the Linode dashboard. And here I have my test instance, so I'll click on that. And I'll go to the storage tab right here, and what I'll do is create a new volume. So I'll just call mine Fedora Btrfs. I'll go ahead and create the volume. And we get all the commands right here that we can use to set up the volume, but I'm going to ignore this for now because I want to do something fun. I mean, yeah, these commands would absolutely get this volume mounted and set up and ready to go, but what I want to do again is set up a Btrfs implementation, so I'm going to handle this manually. So here on the Fedora instance that I'm already connected to, let's type lsblk, and as you can see, we have SDC at the very end. So that's our new storage device. So we have a disk, and now what we're going to do is create our Btrfs implementation. But in order to do that, we will need the user space utilities installed first, because without those, even though Btrfs itself is built into the Linux kernel, we can't actually work with it unless we have the user space utilities installed. So what we'll do is just type which Btrfs. And in my case, I show output here for that command, so Btrfs, the utilities at least, are installed and are available. So we should be good to continue. So anyway, we have /dev/sdc, our new volume right here. So to get Btrfs going and actually use that device with Btrfs, what I'll do is I'll type mkfs and then Btrfs. So makefs.btrfs. And then the actual device is going to be /dev/sdc, just like that. So I'll press enter and let's see what happens. And there we go. We should actually have our very own volume right here of Btrfs. And all we had to do was run that one command right there, which isn't all that different from other commands, you know, like other commands that format devices. For example, if we wanted to do extended 4, then the command would have looked like that. But we wanted Btrfs, so what we did is we actually ran makefs.btrfs. We gave it a device, and now we should be good to go. Now, just like with any other file system, we will need to actually create a directory where we will be mounting that device to. So we'll run make dir. And randomly, I'll just say /mnt. That's always a good place to put these kinds of things anyway. And underneath that, I'll just call it Btrfs-data. So now that directory does indeed exist. And what we should be able to do is mount that device. Let's see what happens. So I'll type mount /dev/sdc. And I'll mount it to the directory that we've just created. And as you can see, it's right there at the end. It tells me that we have 20 gigabytes available, and it's mounted at /mnt/Btrfs-data. Now, as an aside, even though I use the df-h command, that's not really something that you want to make a habit of when it comes to Btrfs, because that can be unreliable. The df command is not always going to take everything into consideration that Btrfs might be using, you know, like snapshots and everything that's related to that. I only use df-h here out of habit just to see that it was mounted, and as you can see, it is. I could have simply just ran the mount command like this, and we see the Btrfs device there at the end. Either way, we know it's mounted, so far so good. Next, what I'm going to do is walk through the process of creating a subvolume. Now, earlier we did this already, but that was a snapshot. What I want to do right now is just create a standard subvolume. And to do that, what I'll run is, of course, Btrfs, and then subvolume. We want to create a subvolume, and we'll type the path to the device that we've just created and mounted, Btrfs data. But what we want to do is give the subvolume its own name. So what I'll do, I'll just call it myvol-1. I think that's good enough. So I'll press enter, and it says create subvolume. There's no errors here. I know for sure there's no errors because I've just checked the exit code. So if I didn't know any better, I would be under the assumption that it did in fact create that subvolume. So if we check a list of subvolumes here, we can see that we have myvol1 listed as a subvolume. So we were actually able to create a subvolume right here with our test implementation of Btrfs. Now, before we go any further, I just want to underscore the fact that you really shouldn't make it a habit to use df-h to understand fully how much space you have left when it comes to your Btrfs device. In this case, I would argue that it probably is accurate, but then again, I haven't even saved anything on that device yet, so it really doesn't matter. Again, the df command, as well as du and possibly others, are going to be a bit inaccurate when it comes to figuring out the storage or available storage space of your Btrfs implementation. So what I would do instead is make sure that you're using the Btrfs user space utilities to determine the amount of free space that you might have. So for example, we could run Btrfs. And as an aside, I was using sudo at the beginning of the video, but now I'm logged in as root. I don't need to do that anymore, so I just start with Btrfs at this point. We'll type filesystem, df, and then we type the path that points to the subvolume, in our case, /mnt/Btrfs data. And here we actually see how the storage breaks down. So I recommend that you use the user space utilities when it comes to figuring out how much space you might have available. So at this point, let's play around with snapshots again. Snapshots are awesome, and I would definitely welcome another opportunity to play around with that, so let's do it. What I'm going to do is just create a simple text file. And I'll create the file underneath the subvolume that we've just created. I'll name it example_file.txt. Some random text. I think that's good enough. Let's save the file. And there we have the text file. Now what I'm going to do is create that snapshot. So again, Btrfs, subvolume, and then snapshot. So we have myvol1, that's our subvolume. And what I want to do is create the snapshot at /mnt, Btrfs-data, and I'll call it myvol1 snap. And it looks like we have a snapshot. And as you can see, we have it listed right there. myvol1 snap, that's our snapshot. So we have a snapshot. That's pretty cool. So at this point, we have our original subvolume as well as the snapshot. And to show that, underneath the /mnt directory, and then Btrfs data, we have myvol1 as well as myvol1 snap. And if we take a look at the original subvolume, we have example file.txt. And if we take a look at the snapshot, we also have example file.txt. So both of these actually are mounted independent of each other, but these are subvolumes. So I could reference two completely different versions right here. Now, of course, if I had a bunch of changes that I've created to the original that might not be in the second or vice versa, I can copy files between the two of them to sync them up. There's also additional tools that we can use that go beyond the scope of this video. For example, we have timeshift. That's a popular utility to use with Btrfs. We also have snapper as well. That's a SUSE technology, but you can also use that in Fedora in addition. So we definitely have additional tools that we can go over, but right here I just showed you the very basics of Btrfs, especially when it comes to creating subvolumes as snapshots, and there's definitely additional features that we might go over in an additional video. But for right now, the whole point was to show you guys the basics, and that's exactly what I just did. So now that we have the basics out of the way, the foundation is all set, and if you guys would like me to do so, I could always come back to Btrfs and explore more advanced concepts going forward. If that's something you would like me to do, then let me know in the comments down below. Alright, so hopefully this video was helpful when it comes to the basics of Btrfs. Btrfs is a huge topic. I mean, there's all kinds of features that we haven't even had a chance to go over yet. So if Btrfs actually interests you, then let me know in the comments below if you'd like to see me do additional content around Btrfs. And if you click that like button, if you did happen to like this video, then the more likes this video gets, the more I'll understand that you guys would like to see additional Btrfs videos on this channel. Anyway, thank you guys so much for watching. This was a lot of fun. Btrfs is awesome. I really enjoyed checking this out, and I hope to do additional videos around this subject if you guys would like me to do so. But in the meantime, thank you so much for watching this video. I really appreciate it.